All right, guys. Let's see. Is anybody out there? Anybody got questions? All right, questions. I have a feeling this is pretty much going to be a short stream. If you can see the blue strip on the bottom here, I got to fix that. Discontinuity. What do you mean by discontinuity? You have questions about it? Do you like to talk about the removable discontinuity? The whole aspect of it. Okay. So I think the best way for me to explain the whole aspect of discontinuity and is to work a couple problems here so you kind of understand what's going on. So I'm going to actually work on day 2, number 1. So let me note it down here real quick. So we have f of x equals 3x squared plus 20x minus 63 all over x plus 9. Okay, so let's just factor this first, and then I'll start talking about discontinuity and what it actually is and how we can actually find it. Then we'll graph this, and it may actually help you out to actually see the graph. All right, so let's factor this top here. So 3 times negative 63. Did I bring the calculator in here? I don't think I brought the calculator in here on the ottoman. So 3 times 63 is 189, negative 189. You have to adjust the camera because you can see the blues on the bottom and everything else. It's higher this time. So don't mess with it now, it'll be fine. Alright, so then we're going to look for the factors that are going to add up to 20. Let's see, 2 doesn't go in, 3 does. So 3, 189 divided by 3. 63, that's not going to work. 4 doesn't. 5 can't. 6 can't because it doesn't have a 2. 7 maybe. Yeah, 7 and 27. Alright, and then because it's a positive 20, it's going to be a negative 7, positive 20. This will give me my negative 20, so that top's going to factor to 3x squared minus 7x plus 27x minus 63. We're going to group these. There's a plus in the middle. This has an x in common. This leaves me 3x minus 7. And then this has a 9 in common. Leaves me with 3x minus 7. Okay. So then the top factors to x plus 9 and 3x minus 7 all over x plus 9. Okay. So here's the deal with discontinuity. Really, we're simplifying the function, and we're going to take something out. So this is actually going to be called a removable discontinuity or a hole, because I can actually take this out right here, and this reduces to a linear equation, 3x minus 7. Well, then we know that x plus 9 equals 0. We're going to do this so we can find out what's going to create this 0 over 0 type scenario, which we can't have because this is an indeterminate form. You won't learn how to deal with that till calculus. So here we're just going to subtract 9, and we know that x equals negative 9. To find the y value, we plug it back in. So we're going to get 3 times negative 9 minus 7, which gives me negative 27 minus 7, which is negative 34. All right, so this gives me a whole, or what's called a removable discontinuity at negative 9, negative 34. And that's fine, that's all the math. But here's what it means. If I am going to graph this rational function right here, I have to simplify it first, and it simplifies to 3x minus 7. Well, 3x minus 7 is nothing more than a line with the y-intercept at negative 7. So this is negative 7 right here. It's got a slope of 3, so it's going up along the lines of this and down like this, right? So this is the equation of 3x minus 7. But it's actually the equation of my f of x, which is the 3x squared plus 20x minus 63 all over x plus 9. All right, so the 3x minus 7 is the line, but we want the graph of this. Well, to get the graph of this, we have to take this point out. So if we're at negative 9 and negative 34, let's just call this right here negative 9, negative 34. So right there, that point is negative 9, negative 34. So what's happening is when I graph this, the reason why it's called discontinuity is because when I first graphed this line, I didn't have to pick the marker up. It was continuous. But now if I wanted to finish graphing this, I would be drawing. I would have to skip this point and pick up on the other end. That's what discontinuity is parts of the graph we have to skip because we're going to get something funky like 0 over 0. So this is how what removable discontinuity looks like. This is actually called right here a hole. So that's kind of the idea of removable discontinuity. So I'm going to work one with the vertical asymptote and could talk about that type of discontinuity as well. Okay, so I'm going to jump over to day 3 to talk about the vertical asymptote. Let's do, you know what, let's just do number 1. We have h of x, that 508. You got it? You need to know the time? No, 8:05. I looked at the actual computer time. So h of x equals 1 over x squared plus 4x plus 4. Okay, so here I'm asking you to find the vertical asymptotes, which is another form of discontinuity. The whole is called removable discontinuity because we remove that part out of the rational function when we simplify. This part we're not going to take anything out. So I need to factor everything like always. So I have 1 over, and this is going to be x plus 2 times x plus 2, which is 1 over x plus 2 squared, because I have 2 of them. Okay, from here, to find my vertical asymptotes, I just set my denominator equal to 0. So I'm going to do x plus 2 squared equals 0. So I take the square root of both sides, and I'm going to get x plus 2 equals 0. Subtract 2, and I have an equation of x equals negative 2. All right, so let's kind of look at this graph here. So what I have is I have a graph. Here's my xy, my origins right here. I have x equals negative 2. So over here where it's negative 2, I have a dashed line. That is actually a vertical asymptote. We cannot cross this vertical asymptote at all because if we do, we're going to divide by 0, and we know we're not allowed to divide by 0. Now, if we would have finished out this series of how to graph a function, I would show you how to find the behavior around the asymptote. Instead, I'm just going to put this in the graph because what I would do then would just confuse you. So I don't want to do that. So I have 1 divided by parentheses. I hope if I put it in the calculator right. Why, oh why is it that? 1 divided by x plus 2 squared. It's a decay. Never mind, this is a bad example. When I actually go to graph this, this is a bad example. This is a bad example, Jay. Sorry about that. Yeah, I'm doing a different problem. This is a bad example. Let me graph these first. Yeah, so we'll do a vertical asymptote one. Man, this thing is just... this is why I'd rather do it by hand than just put it in a freaking calculator. I just want to look at the graph before I actually work it out. Yeah, it doesn't matter. Not for this. Okay, this has got vertical asymptotes. All right, so I'm going to do number 5 on day 3. Sorry about that, Jay. The other one I gave you was actually a decay function, exponential decay function, so that didn't necessarily work well for vertical asymptotes. Shouldn't have even put that one on there, to be honest with you. So I'm going to do number 5. And this is j of x equals 2x squared minus x over 6x cubed minus 21x squared plus 9x. Same thing, we're going to look for a vertical asymptote. This actually has vertical asymptotes. So the first thing we'll do is factor. So we're going to factor the GCFs out. I've got an x on top, and that leaves me with a 2x minus 1. And then on the bottom, I have a 3x. I want to factor that out. And that leaves me with 2x squared minus 7x plus 3. This is going to give me 6, so it'll be -1, -6. So side note, 2x squared minus 6x plus a negative x plus 3. This gives me 2x. This leaves me with x minus 3 minus 1, x minus 3. So the bottom finished factoring to this. So we've got x over 2x minus 1 over 2x times x minus 3 and 2x minus 1. Okay, so first thing we need to do, we need to find the holes. We need to reduce this. These x's go away. I know I'm going to have an x at 0. And if I put this in, I'm going to have a point at 0. 0 is a hole. All right. So this leaves me with 2x minus 1 over 2 times x minus 3, 2x minus 1. Did I give you the time for this one? 1448, roughly. Oh, okay. From here, we're going to set these equal to 0. X minus 3 equals 0. This gives me x equals 3. That's a vertical asymptote. And then we have 2x minus 1 equals 0. Therefore, x equals 1/2. So when we graph this, I know I'm going to have a hole right here at the origin. Not right. I am just not. This isn't right. I have to put 0 in here. I get -1. -1 over 2 times -3 times -1, which is 3, -1, 6. So 0, -1, 6 is where my hole's at. So down in here somewhere is a hole. I have a asymptote at, let's see, at 3. Call this x equals 3. Another asymptote at x equals 1/2. Now, when I graph this, the graph's going to be doing something like this or like this. In fact, when I look at this, it's coming down something along the lines of this right here. And then something on the lines of this right here. And then there's something going on in the middle here. It could be something like this. I'm not 100% sure. I'm not going through all the tests. So that would actually be the graph. That's why I don't want to go through the whole process of how to figure out, especially this middle part, to see where we're actually at. But when you graph this, if you notice, as I'm going this way, I had to pick my marker up. That's because of the whole discontinuity. Goes down to the vertical, all the way down, close to the vertical asymptote. Doesn't cross. Here, then I had to pick my marker up again and then graph this middle part. Then I had to pick my marker up again and graph this last part. That's the whole point of discontinuity, is these breaks in the graph where we can't just draw it continuously. So I hope that helps you out. Discontinuity is kind of a tough thing to try to figure out on your own, and if we were in class, it would make a whole lot more sense because I can actually come over and talk with you one-on-one and show you. And on top of that, if we finish this out, you would understand actually what's going on. But the school has changed up where we can't give you new stuff anymore. So we can't finish this out, even though you were 2 lessons away from knowing how to actually graph this. All right, what else? What else? What else? What else? Jay, did that kind of help you with the idea of discontinuity? All right, cool. Yeah, the whole idea with this, discontinuity is going to come up a lot. Not so much in your next class, which would be either AQR or pre-calculus, but it comes up a ton in calculus, the idea of discontinuity. All right, any other questions? I know this week's stuff was pretty basic. Next week's not going to be much different, except I'm going to give you an option where you can actually start writing. One of the options for next week in Algebra 2 is you can actually write an essay about math. So we'll see how that goes. Hey, who are you talking to? Okay. All right, then. What else? What else? Any questions, guys? I didn't think there'd be a lot of questions probably this week because the stuff I gave y'all are pretty basic. Next week, I expect more questions unless y'all choose to do the essay. Oh, good times, good time. Oh. See if I can get the Coda cam working. Coda's getting a bath right now. Don't know why this thing doesn't work. All right, questions. There's 5 people on here now. What questions do y'all have? Somebody's got to have questions. Can do pretty much anything. I've had students ask me, former students ask me calculus questions. So I'm fair game. What do y'all need help with? Nobody needs help. People just standing here, sitting here, watching me. I'll play my Rubik's Cube until y'all decide y'all need help. Questions. Anybody got questions? Algebra 2, geometry, pre-calculus. This week or last week? Anybody? Test for rectangles. Day 3, 1A. All right. Oh, dude, that was like a while ago. That's from like 2 weeks ago. Let me go find it. Let me find it. Should be that one. Test for rectangles. All right, so we have point A, which is 9, -1. So 9, -1. We have point B, which is 9, 5. We have point G. Wow, I just started labeling them. A, B. This is actually D. This is actually F. Help if I use the letters that are on your page. We have point G, which is -6, 5. And then we have point H, which is -6, 1. Guys, what I'm going to do in the future is I'm actually going to actually in the description put the timestamps of when I work these problems. So if you miss a live stream, you can go back and look because I've actually worked this problem before. But let's do it anyway. Okay, so the first thing we need to do is we need to look and see, is this even a parallelogram? So the first thing we'll do is I'm going to do a rough sketch so I get an idea of my D, F, G, and H, which size I'm going to need to use. So I've got 9, -1. This is A. I have 9. So 9, 5. This is B. Not B. This is F. I've got -6, 5. This is H. And I have -6, 1. And this is H. This is G. This is H. Okay. So even when I graph this right off the bat, I can tell you that this is not going to be a rectangle. Simply because these Y's should be the same. Like these Y's are the same here. These X's are the same. These X's are the same. But these Y's would have to be the same for it to even have it, for it to be a rectangle, for it to have a chance of a rectangle the way it's oriented. But let's do the math to show you why it's not a rectangle. First and foremost, we have to prove this is a parallelogram. So to prove this is a parallelogram, I'm going to use my slope. And I know that opposite sides of a parallelogram, the slopes have to be the same. So if I find the slope of GF, which if you remember my slope formula, is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So if I find the slope of GF, that should equal the slope of DH. So this slope and this slope, because these are opposite, should be the same. If they're not, it's not a parallelogram. If it's not a parallelogram, it cannot be a rectangle, because a rectangle is a parallelogram. So let's do this. So the slope of GH. Okay, easy enough. So let's look, GH. So we're going to do y minus, so 1 minus 5, 1 minus 5 over negative 6 minus negative 6. This gives me a negative 4 over a negative 12, which gives me a 1/3 when it's reduced. All right, so there's my slope of GH. So if my slope of DH is not positive 1/3, not a parallelogram, therefore it's not a rectangle. All right, so here we go. Slope of DH. So let's see, DH. Did I do the right one? What am I doing? DF. DF. DH. Wow, I am not into it today. This is wrong. So GF, 5 minus 5 over negative 6 minus 9, which gives me 0 over negative 15, which gives me 0. Okay. Now we're doing DH. So DH is going to be 1 minus a negative 1, 1 minus a negative 1 over negative 6 minus 9. This gives me 2 over negative 15, which does not equal 0. So since these slopes are not congruent, it cannot be a parallelogram, and since it can't be a parallelogram, it would not be a rectangle. Now, what happens if, let's play a what if game. Let's ignore this, and let's say I get a slope of these lines. We're going to ignore these points and play a what if game. Say the slope of GH was 1/3 and the slope of DH was 1/3. Then we had the slope of, this is G. So GF and DH. And then GH and FD. All right, and let's say this was negative 3 and this was negative 3. Now, if you look, my opposite side slopes are parallel because they're the same. So that would make it a parallelogram. Now, if I look at my intersecting slopes, like GH and GF. So GF is 1/3 and GH is negative 3. Well, that's the negative reciprocal. So I actually know, since these are negative reciprocals, that GF is perpendicular to GH, which means they meet at a 90-degree angle. And from there, where it goes through the whole thing, and you would actually have opposite sides being parallel and 4 90-degree angles, internal angles, which would have made it a rectangle. So this scenario right here will give you some sort of rectangle. You have to look at your intersecting, if it's a parallelogram, you look at your intersecting segments, take if they are the negative reciprocals, they're perpendicular, which would make it a rectangle. All right, what else? I am on fire today. I have had all types of mistakes. What other questions? What other questions? Oh. No idea why that's not. All right, questions, guys. Questions. Huh. Questions. I promise I'll get into it where I won't make as many mistakes, but I am on fire right now with the mistakes. Good times. We'll go play Zelda here in a little while. No questions, guys? Was this week's stuff too easy for you? Test parallelogram day 1, 2B. All right. So this is really kind of the same idea what we were just doing with the rectangle. Is I have point A, which is 5, 6. Point B, which is 9, 0. Point C, which is 8, negative 5. And point D, which is 3, negative 2. All right. Let's do a rough sketch of this graph. 5, 6. This is A, 9, 0. This is B, 8, negative 5. This is C, and then 3, negative 2. This is D. So it kind of looks like a parallelogram, but don't trust your eyes. Let's do the math. So what we need to know is the same idea. We want to know that slope AD equals slope BC. Also, we need to know if slope DC equals the slope of AB. So if these two statements are true, it's a parallelogram. If they're not true, it's not a parallelogram. All right, so we're really just looking for opposite sides if they're parallel. So let's figure that. Let's do this. My slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So here we go, AD. So we got negative 2 minus 6. We have negative 2 minus 6 over 3 minus 5. This gives me negative 8 over negative 2, which gives me 4. All right, so let's do slope of BC. Now, if I don't get 4, I can stop because at that point they're not parallelograms. But if I get 4, I need to check this next one because they both have to be true. But it only takes one not to be true for it not to be a parallelogram. All right, so BC. We've got negative 5 minus 0 over 8 minus 9. All right, this is going to give me negative 5 over negative 1, which gives me 5. Hey, guess what? Because slope AD is not parallel to slope BC, this is not a parallelogram. Because these two right here don't match. They have to match for it to be a parallelogram. Then you have DC and AB. If these were the same, you would check the same with DC and AB and go from there. All right, what else? What else? What else? Be interesting to see what Governor Abbott says about reopening the state of Texas. Day 2, 1A. Right. All right, day 2, 1A. Okay, so I have point A at -6, -3, point B at 2, -3, C at 4, 4, and D at -4, 4. And it's asking you to use the midpoint to actually find out if this is a parallelogram. So the first thing I need to do, let's do a rough sketch so we kind of get an idea of what's going on. So I have -6, -3. This is A. I have 2, -3. This is B. I have 4, 4. This is C. And then I have -4, 4. This is D. So it kind of looks like a parallelogram, but we have to do the math to make sure. So what's really nice about this is these parallelograms have diagonals. And the diagonals bisect each other. So what that means is this point right there is the midpoint of both of those segments. So I just simply need to, I just need to calculate the midpoints. If they have the same midpoint, then they bisect each other, then this is a parallelogram. So really what I need is, I need the midpoint. I need the midpoint of DB to equal the midpoint, segment DB, the midpoint of segment AC. Now, if you remember our midpoint formula, which is really just the average of my x's, x sub 2 plus x sub 1 divided by 2, y sub 2 plus y sub 1 divided by 2. So this is my midpoint formula. So we calculate these midpoints. If they equal each other, it's a parallelogram done. All right, so let's look. DB. So we've got DB. So the midpoint, so I'm just going to write mid of DB. We're going to take the average of my x's, which will be -4 plus 2 divided by 2. That's a 2. And 4 plus a -3 divided by 2. When I do this, I've got -2 divided by 2, which is -1. And this gives me 1/2. Okay, so that's the midpoint of DB. If the midpoint of AC equals the midpoint of DB, that's a parallelogram, and we are done. So here we go. Wow. So we're going to do the midpoint of AC. The midpoint of AC, we're taking the average of my x's, which is going to be AC 4 plus -6, 4 plus -6 divided by 2, and 4 plus a -3 divided by 2. This gives me -2 over 1, which gives me a -1, and this gives me 1/2. So since these midpoints are the same, this is a parallelogram. So we can say it's a parallelogram because the midpoints do bisect each other. All right, what else? What else? Yeah, but I already have a timestamp for that one.
Okay, I didn't know where you were.
Yeah.
I'm sorry, I wasn't sure if I could go give the dog a bath. I didn't pick him up here.
I can't get the Kodacam to work. So it's the app I use is picky. Sometimes it works fine, and other times it just cruds out. I might try it wired, but if you remember before, we tried it wired and it was still. Oh wait, is that the? Yeah, that's the HD one. Yeah, that's fine. So you need a table for the printer so you can get your ottoman back. What other questions, guys? So you have to fine tune the, huh? 1B. The distance and slope formula. All right. I'll tell you what. Let me do a different one because I've already got that one worked out. But I'll do one with distance slope on B, on 1B. Well, 1B is asking you to do something different. Still confused about 1A. Let me do 1E then. So I'm going to do 1E. It's 4152. So 1E, it's the same idea of a midpoint. So we have point A, which is 5, 6. What's he doing? Yeah. B is 9, 0. C is 8, negative 5. And D is 3, 2. Okay. So we need to do a rough sketch. Always do a rough sketch to kind of get an idea so you get all your points in line. Because when I look at this, I can't picture it in my head. I need to sketch it out. So I've got 5, 6. This is A. I've got 9, 0. This is B. I've got 8, negative 5. This is C. And D, we have 3, 2. Okay. So we've already worked these same points earlier. These are the same points, I believe, as 2A. Nope, not at all. They look similar. So what I need to do for this midpoint is I have my diagonals here. This point right here, it has to be the exact same point. If it's not the exact same point, it's not a parallelogram. So I need to find my midpoint. So my midpoint formula is the average of my x's. The average of my x's. So I need to have the midpoint. So the mid of dB has to equal the midpoint of AC. So as long as this is a true statement, it's a parallelogram. If it's not a true statement, it's not a parallelogram. So all I need to do is calculate these midpoints by using this midpoint formula. And I'm looking to see, do I get the exact same answer? That's it. Don't overcomplicate this. If they're not the exact same answer, it's not a parallelogram. If it's the exact same answer, then it is a parallelogram. All right, so let's do this. So the mid of dB. So dB, so 3 plus 9 divided by 2, and 2 plus 0 divided by 2. This gives me 12 divided by 2, which gives me 6. 2 plus 0 is 2, divided by 2 is 1. So it has a midpoint of 6, 1. So just the segment dB has a midpoint of 6, 1. If the segment midpoint, if the midpoint of AC is not 6, 1, then it's not a parallelogram. If it is 6, 1, then it is a parallelogram. So let's check. So AC, so we have AC. So here we go. Average of my x's. 8 plus 5 8 plus 5 divided by 2, and negative 5 plus 6, negative 5 plus 6 divided by 2. All right, so let's look. 8 plus 5, that's going to be what, 13, right? 13 over 2, that doesn't simplify. 13 over 2, I will give you the decimal form of this in a second. And then negative 5 plus 6 is 1/2. Well, in decimal forms, this becomes 6.5.5. If I look here and I look here, if those are not identical, it's not a parallelogram. If it's identical, then it's a parallelogram. The last example we did, those were identical, so it was a parallelogram. In this case, these are not identical, therefore this is not a parallelogram. That's all this is with the midpoint. That's it. I don't need the end time, I just need the start time. 46:20. What did you do?
Stop! Stop! I don't even know which way they're going to.
Wow, he moved it a lot. I'll get it. You're moving it the wrong way. I'll get it. Because it's a mirror image. All right, did you still want me to do number 2? I mean 1B? You still want me to do that one? Is that yours or mine? Wasn't mine. Okay. So, like I said before, I have if you go back on 4.1 in the live stream at 1848, you can see that exact problem worked. So I'm going to work a different one with the same scenario. I'm going to work C. B and C both say use the distance and slope. This way, if you want to write it down real quick, I'll tell you the 47:58. So on 4.1, if you go back and watch the video on 4.1, at 1848, you'll actually see 1B worked out. I'm going to do 1C, which is the same idea. So they moved the camera again. I'm about to not let them in here. So we have point A at -2, -8. We have B, which is 4, 4. We have C, which is 6, -3. And we have D, which is -1, -7. All right, let's do a sketch. -2, -8. This is A. 4, 4. That is not 4, 4. 4, 4 is in quadrant 1. This is B. 6, -3. This is C, and D is -1, -7. This is D. Okay, so we're going to use distance and slope. So what we need to do is we need to prove that exactly one pair of opposite sides have the same distance and the same slope. That's it. So I need my slope formula. Is y2 minus y1 over x2 minus x1. And I need my distance formula, which is d equals x2 minus x1 squared plus y2 minus y1 squared. And of course, we take the square root of the whole thing. So there's my distance formula. Sorry, I ran off the board a little bit because they moved my camera. All right. So let's do slope first because that's the easy one to calculate. Let's just pick sides. So let's do the slope of, let's do BD. Slope of BD is going to have to equal the slope of AC. The other contingency is that my distance, these are segments, and I don't actually need to write, I want to write it out anyway. The distance of BD equals the distance. Yeah, I can help you with polynomials. The distance of AC. Let me finish this problem and I'll help you with polynomial. Just let me know which one you need. All right, so let's do the slope first. Both of these have to be true for it to be a parallelogram. If one of these is false, then it's not a parallelogram. If they're both true, then it's a parallelogram. So let's do the slope. All right, so here we go. Slope of BD. So here we go. So we've got -7 minus 4, -7 minus 4 over -1 minus 4, -1 minus 4. This gives me -11 over -5, which gives me 11/5. That means that the slope of AC better be 11/5. If it's not 11/5, it's not a parallelogram. Easy peasy. If it is 11/5, then I go to my second thing that has to be true and check the distance formula. All right, so here we go. Slope of AC. So we've got -3 minus 8 minus a -8, -3 minus a -8 over 6 minus a -2. 6 minus a -2. Well, this gives me 5 over, I already see that's not going to work, 5 over 8. Because these two right here are not identical. This can't be a parallelogram. It fails right here. It's not, this isn't true. So it can't be a parallelogram. If this was true, then you go and use the distance formula and get the exact same number. That's what you're looking for. What do you mean by adding and subtracting them? Do you have specific problems in mind? I'm going to readjust my camera so I'm not writing off. Let me know which problem you want. You just want me to pick a random problem for adding and subtracting polynomials? This is from now 3 weeks ago. 2 weeks ago's work. Oh, I need to go. Goes back. There we go. 2x times 3y plus 2x times 5. That is not adding or subtracting polynomials. I don't even know if that's in the packet. So you have this. 2x times 3y plus 2x times 5. Is that what you want? Because you're going to be really, really disappointed on this. We'll wait for you to say yes or no if this is what you actually meant by what you typed in. All right. Super easy. This isn't, well, yeah, I guess this is a polynomial. I'm used to rational functions. So the first thing you want to do is let's multiply my numbers together on each term. So this is a term right here. That's a term. And this is a term. So when I say terms, I'm looking at anything that's broken up by the plus or minus signs. All right, so let's do 2 times 3 is 6. Then I just have an x, and then I have a y. So there's my first term. Plus 2 times 5 is 10, and then an x, and I'm done. That's it. Because these are not alike, I can't combine them, and that's that. I'm done. That's it. One line. What else? So yeah, multiply your numbers and then multiply the variables. If they're identical, then you can combine them, but if they're not identical, you can't combine them. Any other questions, guys? Anything else? Anything else? You are welcome, Chat Ricky YT. Day 3 rectangles 1B. All right. Okay, so here we go. We've got day 3. We have 1B. We have point D, which is -4, -3. We have point F, which is -5, 8. We have point G, which is -6, 9. And then we have point H, which is 7, -2. Okay, let's do a rough sketch. I've got -4, -3. This is D. -5, 8. This is F. -6. Let's see. -6, 9. This is G. And then 7, 2. 7, -2. Guys, even by sketching this, I could tell you that this ain't going to be a rectangle. All right, so what we need to do for this to be a rectangle, we need to have the slope of GF equal the slope of DH. And then we need to have the slope of GD equal the slope of FH. If I write these down right, -4, -3, -5, 8, -6, 9, and -7, -2. All right, so if these slopes are not exactly the same, then it's not even a parallelogram, which can't be a rectangle. All right, so let's do this. The slope of GF. I should probably write this time down. 59:17. All right, the slope of GF. So let's see. GF, so 9 minus 8 over -6 minus a -5. -6 minus a -5. This gives me 1 over -1, which gives me -1. So if the slope of DH is not -1, we're done. It's not even a parallelogram. They can't be a rectangle because it has to be, both of these have to be a true statement. All right, so now let's do the slope of DH. So DH. So here we go. -2 minus a -3. -2 minus a -3. And we've got 7 minus a -4. 7 minus a -4. This gives me 1 over 11, huh? -1 and 1 over 11, they're not the same. It's not even a parallelogram. If it's not a parallelogram, it can't even be a rectangle. So that's pretty straightforward. All right. So yes, Hosford, you are correct. The district has kind of changed it up. They want us to assign you one topic a week for about 45 minutes worth of work. So you're only going to have 45 minutes worth of work for each of your classes, supposed to be. And they want us to give you at least 2 options you can pick and choose. So this week, option 1 and option 2 in geometry are pretty close to being the same. Actually, they're not. One's like a game that you can play. Just take a screenshot of your picture and send it to us. And another one's just problems. Next week, and then next week, working on it right now, you're going to have an option between working problems or writing short answers, explaining in short answers how to solve the problems. So either you can do the raw math or you can do it like a written assignment type deal for it. So this way you're only going to have one assignment every week that should take you about 45 minutes. Which will make grading on me a whole lot easier instead of having to grade 3, 4, 5, 6 different things. All right, guys. I'm going to shut the stream down. I'll be back up at 5 o'clock tomorrow if you have some questions. But I have a feeling with this week's in geometry, it was pretty straightforward, and this week in algebra 2 is pretty straightforward. I don't think there's going to be a lot going on the stream. But I'll be here at 5. So if you have questions on that, I'll be back up at 5 tomorrow.